online app basically that replaced Flash. So you would log into the website, build out this big Flash animation. It was all using Canvas at the time. It was pretty involved. I don't even know if I have it hosted anywhere at this point or not, but it was pretty involved. Like you could build out these animations, edit them, save them, etc. And then when you're done, you click export. It gave you like a little JavaScript snippet. You would plug that into your website and it would just load up and play the animation, just like you would expect from like a Flash. So it was pretty cool. Definitely had a lot of fun with it. Learned a lot about Canvas, etc. And then I actually was a member of another meetup down closer to my house. I live out in Mesa, and one of the guys was like, hey, can you do a presentation on Canvas? So I did, and then I had all the files still. So when the opportunity came up, I was like, I'm jumping on it. So I haven't worked with actually Canvas in a little while because I stopped working on my little side gig. It became pretty ambitious. Needed to pay some bills, so I started working on other stuff, and kind of this is where it ended up. But learned a lot in the process, and it was a lot of fun. So if you guys, very informal. If you have any questions as we walk it through, go for it. Other than that, I guess I'll just get started on it. I like to think of the Canvas tag as a whiteboard almost. You can sit there and draw to it. When you're done, you clear the canvas. You can just like erase it and keep drawing again. And we'll work our way up through some animations. I have about 10 HTML pages with like all of the JavaScript and stuff all right here. So we'll just be able to walk through and see what we're looking at. I'll give you a little sample here. This is the Canvas tag. You can see it's just right here, Canvas. I gave it a ID and a width and height, just so we can kind of deal with a certain space there. Each page, I kind of talk about like some things here, like a couple bullet points. So anything between the open and close tag will show on older browsers. We see like this little comment here. This will show on browsers like IE8, Opera Mini. There's not a lot of browsers that don't support Canvas now. The one thing you'd have to watch out for is performance. Like support is a vague concept, right? Like, oh, it supports it, but you can't do anything on it. It's right. So that being said, quite a bit of coverage. I don't know if you guys have used that website at all. It really gives you good statistics on what you can feel comfortable using compared to where your browser cutoffs are in your projects and stuff. So about 85%, I think it's actually, this is when I did the original. I looked at it again the other day, it was closer to like 89%. Pretty good. When you're doing Canvas stuff, I think you're not really concerned about IE7 and even IE8. So I think that being said, you're pretty good on coverage these days. It really is like creating an image on the fly. It's just this Canvas tag. You can write to it, you can fill this buffer, you can render to it, and when you're done, you literally on the web page you can right click and save image as it'll save it out as a JPEG. Oddly enough, so it really is like creating something on the fly. So let's draw a random soup. Where aren't you drawing? This is going to be, oh, there we go. It's taking a little while to catch up to me as well. So draw a random circle. I have this button, and you can see here that we have buttons, and we're just calling some JavaScript on each one of these. We can draw a bunch of stuff, we can clear it, we can draw a bunch of more random circles, and we can clear it. And that's all done through JavaScript. You have this one Canvas tag in and of itself, doesn't really do anything. You draw to the canvas and clear it, etc., all through JavaScript. So we're going to take a look at a couple of, there's only two functions on here. One's draw random circle, and the other one is clear. I call it clear whiteboard, but it's clear canvas. So only two methods. Let's walk through one of these. You guys, I don't know if you're familiar with JavaScript at all. Like you're probably different levels throughout the crowd. So it's pretty easy JavaScript, and we'll just kind of walk through it. If you have any questions, let me know, and I'll try to answer them on the fly here. First thing we want to do is get a reference to that element. We called it whiteboard. That was the ID when we looked at it earlier. So we're just getting a reference to it so we can work with it. The other thing about Canvas, there's basically like two parts. Whenever you want to write to it, you have to get a reference to that, and then you have to get what's called the context. And because we're just working with kind of flat 2D drawings, we're getting the 2D context. If you guys are familiar with a way to do 3D web graphics, it's through WebGL, and it's the same two lines. It's all WebGL is all done through Canvas as well, but instead of getting the 2D context, you get the 3D context. And in doing so, it gives you access to different methods. Like you can create a sphere instead of like a circle. So it just gives you a different reference of a different set of commands. So we're only concerned about 2D at the moment, and so we're just getting the 2D context. And when we do that, this CTX object then allows us to call certain methods, and we'll like draw arc or draw a line. So let's kind of cruise through these. The next step I'm doing here is because these are, I'm just drawing random circles around. I'm just creating some random XY points here. Nothing special. Same thing, the radius, I'm just somewhere, you know, between 0 and 20, create a random radius so it's bigger and smaller. And then angles. If you guys do any sort of drawing, almost all computer drawing stuff is done in radians. It's just one of those things, if you start getting into any computer graphics, it's all done in radians. So for my own benefit, I just wrote this little helper method, degrees to radians, so I can say 360. It makes a lot more sense to me. I don't really work well with radians in my head. Not yet. I'm not that good, I guess. So this is when we actually start drawing the circle. So everything up to this point was just prep. So what we call is the first method is begin path. And I'll talk about that a little more in the future, or in the next slide or two. So this one's just really just to kind of intro us in. So CTX, that was that 2D context that we got. So we have access to these methods like begin path, fill style is red, arc is going to create an arc. And everything that we're doing here is really just writing to this buffer. It's not on the canvas yet. It's just writing to memory. And the last thing we call fill, that's when it writes to the canvas. And I don't know, anybody have any questions so far? We kind of like blazed through a little bit of intro. I know it's kind of a foreign concept, but I have 10 more slides. We're going to talk through kind of a little more stuff, but if anybody has questions, feel free. Making sense so far? Nice, nice.
The only thing that might not make sense is the angle is the whole thing, but if it was 90 degrees, what would be the orientation? Would be facing
Okay,
the first quadrant?
Right. The orientation starts right here, 0. So when we call arc, we're saying where's the center point, X and Y. Here's the radius that we created. So how big is that? This is the start angle. Right here, it's 0, which is actually along the x-axis, and then the angle. So it would go up. If it was 90, it would be a pie shape, kind of like this. If it was 180, it would just be a flat square. If it was 270, obviously, and then 360. So it's counterclockwise. Did that answer your question? Okay.
Definitely.
Okay. Sweet. Sweet. All right. So let's kill this one and go to slide 2, which is I'm a developer, so slide 2 is actually slide 1. I hope that's funny to somebody other than me.
I do it every day.
Right, so there's this little note on here. It's like a clear plastic overlay. Well, if you're familiar with buffers at all, no, sorry, I thought that was me. I was like, great, what's happening? Command plus.
You're on Safari.
Killing me. Thank you. I'm not like a Mr. Mac. I have one, but I don't use them that much. My daughter steals mine all the time.
Mm-hmm.
There we go. Life is whole again. So I have this little comment at the top. It says, it's like a clear plastic overlay. That was that buffer I was talking about before, where you can really just write to it, and you haven't really rendered anything yet, and it's the render methods that cause it to actually go to the canvas. That was just this note up here. We'll talk about it when I get into the actual stuff here. So context, context is like a clear plastic overlay. I don't like that terminology anymore. I think that confused people before. So we'll just kind of bypass that and keep talking about it differently as we get down to the code. Use drawing path methods, arc, rect, etc., to draw the canvas's buffer. So do you remember when I was saying before? Let's get down to some of this JavaScript. When I was like, oh, we'll talk about this begin path method next time in the next slide. Let me give you a demo of this page. So we're drawing random circles. And you can see I have this little checkbox here, use begin path. If I uncheck that, let's look and see what it does. Let me clear this. Oh, there we go. I was like, wait a minute, that didn't work like it was supposed to. Begin path. Let's go through this. I'm sorry. we'll just step through this JavaScript a little bit more. So we're doing the same kind of methods here, getting a reference to the canvas element. We're getting a reference to the context, so that'll give us these methods that we can use to render, like begin, draw, arc, etc. We're choosing some random points again. Random radius, our angle is 360 just so it does a solid fill on it. Here we're saying, is this checkbox checked? And there's a reason for that. We call this begin path method. Begin path is really a way of resetting. So like
multiple layers.
Yeah, exactly. That's a good way to say it. Multiple layers. So if begin path is not checked and I just keep doing arc, 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 I'm not really resetting anything and everything gets rendered at once. So fill style red, draw the canvas buffer, arc, fill. Yeah, I didn't really do a good job of explaining that. That made more sense when I was going through this yesterday. So I apologize for that. I know what it does. I apologize. I'm trying to convey in simple terms what begin path does.
So that there's the buffer. That helps.
Yeah, it is. It's really maybe without this example, I can explain it a little bit better. If I were drawing a line and I start with begin path and then I fill it, I can draw that line. You know what? Actually, you know what? Let me just keep going past this page because we'll get into some other stuff, and I don't want to stick on this one. Begin path is important, but you'll see it develop a little bit more in just a second. So it's probably better just to skip this one and not get hung up on it. There's a nuance about drawing with Canvas. Up until now, we've only done circles. When you start drawing lines, you'll notice that they get really kind of fuzzy looking. And that doesn't look good if you're trying to do any sort of precision or something to look good. And the reason being is that everything's done on pixels. And so, like I have this grid here, for example. So it starts right here. If you're dealing with any sort of graphics and stuff, you're starting in the upper left corner, and you say, I want to come over 50 pixels and down 50 pixels, and I want to start drawing a rectangle. What happens is, here's your pixel grid. You're really starting here. You're not starting here with Canvas. So when you say, I want to come over, like, I don't know, 4 pixels, you're starting here. And if you have a line that's 1 pixels wide, it really fills in. The Canvas tries to do some tweening for you, and it really takes 2 pixels down the side, makes them slightly opaque, and it's trying to help you out by making it look better. It actually looks way worse if you can tell.
It's half
Yes. What's up?
Because it's 2 half pixels.
Right, exactly. It's 2 half pixels. It's really 2 full pixels that are like grayed out, trying to tween it and make it look good for you, or not tween. So there's a way to get around this with Canvas, and really what you do is you offset before you start drawing. You offset half a pixel first, and then come over 4 pixels, and it ends up right in line. And so the demo here, I was drawing some random rectangles. They looked all gray. I have a checkbox here, translate for sharper lines, and we'll go through the JavaScript. You can see they're a lot clean. Well, it's funny because it doesn't look so much cleaner on the presentation here. Let's try without and see if we can, yeah. Presentation, or the slide doesn't help. If you saw the screen, they actually look pretty nice. That doesn't really help though. Let's look at the script up. Kind of same stuff before. We're comfortable with getting context, getting a reference to the Canvas element, picking some random start points. We have our width and our height for our rectangles, and then we're saying if it's sharp lines, we're really just getting a reference to this checkbox and saying if it's checked, do something a little bit different. And we do this little translate first. Translate is really just saying move X and Y before you start drawing anything. And so we're moving half a pixel and half a pixel, and then we're taking our start X. So what it does is, yeah, it just puts us right on a pixel, set right on a half pixel.
If you control zoom in on that canvas, you should be able to blow up to show.
It would be,
The mouse or?
Hold down control and then 2 fingers scroll up. Or sorry, hold it. You hold down.
Yeah, control and command, neither.
I just start using the menu view. Like it'll just zoom.
Oh, yeah.
Well, that's not the same though.
Let's see if it at least gets better for. No, I think it's just increasing the, yeah, it's not really helping out. Well, aside from poor video quality,
Interesting.
yeah, I guess we'll just have to keep going.
The concept's there.
Yeah. The other thing I want to talk about here is that we have CTX save and CTX restore at the bottom. CTX save, so anytime you make changes to properties of the canvas, like fill style is set for everything that you're drawing on the canvas. So if I want to draw a rectangle and I want to draw a circle and maybe a line, if the first thing I do is set ctx.fillstyle to red, and then I do circle, line, whatever, it stays red. So yeah, that context, the ctx.fillstyle is applies to everything that you're drawing from that point on. Save allows you to kind of mark this as something in history. These settings get saved, and it's just a stack. So you could do fill styles red, and then you can do ctx.save, draw a bunch of stuff, and you do ctx.restore, and it goes back to what it was previously.
So if you save 3 times and restore 3
Right.
times, you're
Back to the original place, right? So that way, if you want to draw something that's like you're drawing, something that's black, and then suddenly you have like a square, and you're like, oh, this one's got to be red. You do ctx.save, mark everything as is, change the fill style to red, draw your square, ctx.restore, put you right back to black, and then you keep drawing again. So the big takeaway from this was really that when you start drawing a canvas, one of the first things is really that the lines become unclear, and you have to translate in half a pixel to really clean them up.
What is it saving to?
It's just memory. It's just yeah. It's not just no. You can. It's a push pop, so you can only do a save and a restore. You can't go back in and do like oh, give me 3 back, yeah, or change them. Yeah, it's inaccessible other than those 2 methods.
Meaning, does that apply to like undo kind of things?
It wouldn't. It depends on. I would say probably not undo.
Okay.
It would be one of the options that you would do, and if you're building like your own undo stack, where I want to like undo this last thing that I drew.
Right.
It would probably be part of that. You'd be like, oh, I want to also do a ctx.save and restore in your undo methods that you are making, undo and redo methods. You'd probably do a save and a restore in those just to put it back where it was. But in and of itself, I wouldn't associate it with an undo.
Right. Okay.
It's more of when you're drawing things like I want to do something that's a different color. So I'm going to save all these settings and then do what I need to do and then restore the other settings.
Do you know the purpose of get context? Because I don't see a set context.
There's
I was wondering if there's a set
it's
context.
just determining whether it's 2D or 3D.
Yeah, exactly. It only just tells you whether, there isn't, I don't think there is a set context. No, it's only get context. The canvas in and of itself has those 2 methods, and you would call get context 2D or 3D. That would be the only 2 things.
Gotcha.
So we can actually talk in detail about the save and restore right now. It's state stack to simulate layers like you were saying, essentially. So right now we have a white square and a red square. If we uncheck this, it redraws the canvas for me because I just have a method on there and it turns white. So let's look in and see how that's actually working out for us. So draw rectangles, and this what I have I just have an event handler on here. So as soon as I uncheck this or recheck this, it recalls this JavaScript. So same thing before. We're getting a reference to the canvas element. We're getting the context. Doing width and a height that we're used to draw these squares. We're actually clearing it right away. We're just saying, hey, run that clear method. And let's jump down there since we glossed over it past a couple times. Clear is getting a reference to the canvas element, getting a reference to the 2D context, and then calling clear rect. and it starts at 0, 0 in the upper left. And so what you can do is you can clear like half the canvas if you wanted to. If you start on the upper left side, you can say clear rect and then only clear here, and it will go through and basically wipe out only the area that you selected. Why would you want to only clear like half or a piece of this area? It can come down to performance. Like if you were drawing something, like you can use Canvas to build like games, etc. Like some very performance like applications. It performs really well because it's hardware accelerated in most browsers these days. So if you were building something out and you didn't want to re-render the entire screen, you're like, you know what? I'm just going to clear this one section and re-render this one section, and you can do that, and it takes a lot less time. So it's really a performance thing. Is why you would only want to clear a piece. In this particular case, we're not doing anything super performant. We're just using it as a total wipe and a redo.
Also for like transparency, right?
Yeah, it's
So
true.
if you got
Yeah,
something behind.
yep.
Like
That'd be a perfect piece for it.
Cut a hole out.
Yeah. So let's jump back up here. So in our draw method, I'm clearing it all out. We call this CTX fill style red. So now anything that we draw is going to be red. If this checkbox is checked, we call ctx.save, was what we were doing before. We're saying take all your settings right now, like including this red fill style that we have, save it to a buffer, and then we can do fill style white. We could draw what we want to, and then we call restore, and CTX fill style goes back to red, and then we do another fill rect that's red. So you can see what happens is if I don't have this checked, let's kind of step through this. We kind of set our our random widths and heights. We clear it all out. We set our fill style to red. In this case, use state stack. It's not checked, so it's going to be false. So when we get down to this method, it says if this is true, it doesn't save anything. And when it sets white right here, there's nothing to restore to. It was red before. We set it to white. We call fill rect. We try to restore. There's nothing there. We didn't save anything, so it's still white. And then we draw the second one. It's still white. So we really didn't save that context first. We didn't do a call ctx.save. Didn't save the context. There's nothing to restore to, so both squares end up white. The other thing, Canvas in and of itself, if you notice we got some stripes on here. The Canvas is a tag like anything else, so we have a style on here. This is just a background image. Canvas is transparent on its own. I have a class on here, stripes, which is just a background image on there. So you can do a lot of CSS stuff with the Canvas aside from just drawing to it with JavaScript. As far as like backgrounds and things like that. And the reason I even put a background image on there versus just drawing it out with some sort of image is performance reasons. Like I don't have to render an image to the entire screen now. It's just a background image, and that stripe doesn't get regenerated at all. So it was more of a performance thing when I was doing. I'm like, you know what? I don't need to redraw it every single time. Any questions so far? I know we skipped over that whole begin path thing.
You can make those whatever you want them to be. You create those.
Create
The background image you're talking about.
Oh, yeah,
so stripes
that's it,
is something that you create
Right,
somehow.
right. It was just an image I found online. I'm like, oh, I need stripes,
Okay.
and I found a JPEG, and let's look at it. I mean, it's a class.
Is that all it is? It's a JPEG, or
Yeah, it's right, and so it has nothing to do with Canvas in and of
Okay.
itself. I think my Prezi. Oh, you know what? Let's
Just put on the canvas itself.
So background is just URL stripes. That's just like you would style any other HTML element with a background image. I know, good old Canvas, Prezi. Everybody's quiet. It's complicated, right? Canvas is a little bit complicated. I don't know if everybody's comfortable with it so far. It's fun if you get into it. If you like that, if you like to torture yourself.
would you consider this difficult to use to write with? I mean, is it?
No, you know what? And I didn't bring it up yet. There's a what's up?
Go ahead.
There's a cheat sheet. I'm gonna bring it up since you asked.
Yeah, bring it on. You're talking to a non-developer here, by the way,
Okay.
so it's like all of my questions will be pretty.
Yeah, I would get
Pretty
comfortable with
basic.
JavaScript, but aside from that, in and of itself, open. I think it's loading. There we go. There's this cheat sheet I found online, and it lists all of the methods and all of the properties available for Canvas. And it's only 2 pages. It's only 2 pages long. It's really easy to kind of get familiar with what Canvas can do. There's not a lot to it, but it allows you to do quite a bit.
Yeah, sorry.
No. It was,
What's wrong?
it's all
No,
good.
it's
What I
it
missed.
keeps asking me for stuff. I try to log into something. I'm like, oh, I lost this program too. Now I gotta update that.
So the canvas element has a width and height properties, kind of some general stuff like that. These are all blend modes. What you can do is if you're drawing like a red circle on a blue square, you can, before you draw those, you can say, what is my blend mode? And you can make them kind of opaque, or you can make them Boolean values, etc. So it allows you to, when you're drawing multiple things on top of each other, to blend them a certain way. You can, Photoshop has that, if you guys are familiar with Photoshop. You can set a layers style to like all kinds of, different, I forget what the settings are, but they roughly mirror these. Yeah, they have like XOR and, things like that. So kind of that same thing. And so just in the very simple options that it gives you, you can do so much. Like you could really build a Photoshop clone out of this. You could
If
really
anybody
build,
knows Illustrator, those are like unions for.
yeah.
When do you use this? What are the use cases of this?
Okay, yeah, that's,
Canvas in general.
yeah.
Yeah.
That will be the last slide, but I'll talk about it now. When you really want to do, you want pixel level control over something, would be probably the biggest reason that you would use Canvas instead of SVG or even CSS transformations. When you want pixel level control, you want to be able to like write a drawing app or something to that effect, a Flash clone, something that you're not going to get out of basic SVG or CSS shapes.
Yeah. So a lot of sites are using it for just high like intensity animations.
Mhm.
So like if you've got some crazy stuff flying into the screen and like, animating all over the place and interacting with user interactivity, then Canvas is really good for that. Pretty much anywhere you used to use Flash.
Yeah, that'd be a good, that'd be a really good example. So anyways, this cheat sheet kind of gives you, like there's, here's the settings. These are all the settings that get, when you do ctx.save and ctx.restore, it'd be like stroke style, fill style. Stroke style being like the, how a line is drawn, like is it red, is it blue? You can use patterns as your pen color, like, or brush or whatever you would call it, to draw lines and fill things. Has some gradient options for you. These are the methods that are available. Basically, yeah, just all of these methods are the only things that Canvas gives you, and you build things out of that. Like you could build a brush. Photoshop has like these crazy brushes where as you drag along, it does like random placements, changes the color of certain ones. You could build that all out. You would have to do it through code, and you could do it just using those methods in and of itself. So it seems basic. It really is. It stays out of your way, allows you to do a lot, but there's a lot of legwork, I think, involved in something like that.
It would seem complicated to build a whole like animation just from those shapes out of it, right?
Yeah,
It through JavaScript.
right. Yeah.
There's a lot of libraries that help you though.
Oh, there are.
Yeah.
Oh,
Yeah.
that would be very helpful.
Yeah.
Like hand
And
drawn,
we're
like
kind of
a
working our way.
circle.
We're working our way through the basics of
Okay.
it, but yeah, like if you're really gonna do something, I would probably opt for a library. I have a couple of them at the end as well that I'll bring up. So let me lose this. We'll keep going through the presentation. So translate and rotate. Translate being moving something X and Y. Rotate obviously rotating something. Oh, where's my sliders? There we go. The sliders are not showing, but essentially I have some event handlers hooked up. So as we move this, and I also have one for rotate, we're just rotating those. Right. And really what's happening is it's every time I'm dragging this, it's just clearing the canvas and redrawing, clearing and redrawing, clearing and redrawing. It's not just moving something that's already there. And let's go ahead and look at the code a little bit for this. draw rectangles. This is what gets called as I'm dragging that slider, those sliders back and forth. Kind of same thing before, get a reference canvas element, the context. We're using 100 by 100 for all of those. We're clearing it out. So as we drag, we're clear. The starting point, we're just getting a reference to our X starting point along there, and it's whatever this distance on that slider happened to be. So as I drag it along, you can see it's just moving proportionately, right? It's because our starting X value is whatever that slider was. And same thing with rotation. As I slide it, they were just, it's updating this variable. So this is dynamic and this is dynamic. Call save. We're doing translate. We're pulling this value from the slider. So we're saying before you start drawing anything, move your internal start point to whatever we picked as our start X, and then just go down 50, which is in this upper corner of this white right here. So we're saying move there before you start drawing anything. We're saying also before you start drawing anything, update your current drawing angle to be whatever that rotation slider was. Now we're saying fill style is going to be white. We're doing fill rect, which actually causes this to render the canvas. So we're making a rectangle at 0, 0. And we can say 0, 0 because we've already moved our start point. And then we're just going width and height, which are 100 by 100. We're drawing the second one. In this case, it's red. So we're setting fill style to red, drawing it, and then we're calling restore. And restore puts it back to its original setting, which was orange. I guess we didn't set it to orange. They were setting it to orange now. Calling, you know what? The big thing isn't the fill styles in this case. When I call ctx.restore, I called ctx.save before I did this translate. So I'm saying, when you start drawing canvas, originally, before you do anything, the start point is right here. We talked about that when we had that fuzzy grid that we kind of bypassed. So the start point is always in the upper left. In this particular case, before we start drawing anything, we call context.save, and that saves the current context or this current drawing start point. Then we translate and draw all of these squares out. We move over here, we set the rotation, we draw these squares, and when we're done, we call ctx.restore. It puts our starting point back up in the upper left corner. And then when we get down here to draw this last square, we've reset ourselves back to the upper left. And now we can just say starting point is 50 and 50, and then our width and height is 100 and 100. And we're really drawing off the upper left again. So that was a good example of that state stack. Did you have a question back there? Or?
A little bit. What stood out to me is fill style seems to be global, so you can't have two concurrent functions that are using different fill styles.
That's correct. Fill style is global for the canvas. If I set it to red, and I didn't call ctx.save anywhere, it would be red for everything.
Right. And the pen too, it's always in the last spot that you left.
Right. It's always exactly. And did that? Were you calling it out? Did you have a question about it? Did it seem to make sense to you?
I was verifying it. My
Okay.
question would have been, can you have two functions running at the same time that use different fill styles? And I guess you can.
Oh yeah, you wouldn't be able to know.
Would you be able to grab the context twice and put it in two different objects?
I believe it's the same context.
Yeah, I would think so too. It's a single pointer to the context, so you may be able to use it at the same time, but it would. You'd be fighting yourself. Yeah, exactly. You'd be fighting yourself on it.
You'd have to have two canvases on top of each other.
Which is definitely it's not as bad as it sounds.
Yeah, you really don't have to worry about it because there's no race conditions in JavaScript.
Yeah.
Right.
Well, why would you want to do that? I mean, you're able to do different fill colors. You got three things there, different colors. What are you guys talking about doing?
If you wanted to draw two things at the same time, basically.
There's certain
Well,
forms.
how would you do that?
Forms of programming.
Two
where that
mice
would be
or
really tempting
two?
to do that.
Yeah. Like
You know,
you
you're
have a
automatically-
continuous.
Oh yeah, okay,
Yeah,
I got
continuous rolling background and players moving on the front of it, and
right.
arrows coming in. And
Yeah,
have
no,
all
I
these
got
different
you.
colors, right?
I'm thinking in terms of human interaction, not
Or like, if you have different people running around and you're simulating two people,
Exactly.
then you want to be using different colors.
Right.
And for performance reasons, those people could be on different canvases. So imagine you can actually animate inside the canvas, but you could also move the canvas itself. So you can create a lot of parallax type stuff.
Yeah, you definitely. Yeah. The canvas element in and of itself is not heavy either. You can have multiple canvases. I mean, you could have 20 canvases on here, and it's not a problem. Drawing those all around. Yeah. Yeah.
So how do you determine layers? That's just CSS.
No, there's no actual like within the can. Oh, I see.
Yeah,
Yeah. If you have multiple
then-
canvases, yeah, at that
Then
point,
you're
it's
programmatically altering
Right,
layers.
right. But you'd control it the same as you would any other HTML element at that point.
You have to follow Painter's algorithm if you want layering in the canvas.
Right. So this one is how to interact with something. Boom, check this out. I'm just moving my mouse over it, and it's turning red as soon as I get inside of it. When you really think about it, Canvas, the element that gets rendered to the page is just an image. I mean, it's not like another, other HTML elements or like a div. Or I guess think of this as an image. So when you move your mouse over a particular piece of an image, like how do you make that like change or do something?
There's no internal DOM representation of that
Right.
box.
Correct.
That's the key to that.
Yes, exactly. Yeah, once it gets rendered to the canvas, there's nothing. I mean, you can't go back and say, "Give me that square." It is what it is at that point.
Right, it's like trying to select text on a GIF.
Exactly. Exactly. Man, you have some good analogies. I love it. I really love it. So key points on this. You can come in. You're not bothering anybody.
Give me 1 second.
Okay. Yeah, that works.
He's gathering himself.
Bind to bit handlers to the canvas tag. That's really what you do. So on this, I have a on mouse move, and it's bound to the canvas. I think I have that on the window.onload. I'm getting a reference to this canvas element, and I'm setting my bit handler for mouse move, and it calls check if over element. It's another JavaScript function that I wrote, and then it just calls. So that's what happens as soon as this loads. It creates this method. And so let's go look at how I'm able to do that. So you use context.begin path to start drawing the elements in memory. You don't call fill or stroke yet. Fill and stroke cause everything in the buffer to get rendered to the canvas. So earlier I was trying to explain begin path, and I kind of skipped over it because I knew that I would come back to it. Begin path says, I want to start drawing to this buffer without drawing to the canvas right away. And the reason you would do that is
Drawing in memory, basically.
Yeah, exactly. You're drawing in
It's like a
memory.
transaction.
It's performance. When you actually render everything in the buffer to the canvas, that's the slow part. So it really is low level. It gets you down to the meat of things. But so begin path says start using the buffer. Draw every other command that I do in here, like draw rect, draw arc, draw line, draw image, is all going to a buffer. It's not getting rendered to the canvas yet. It's when you call the two methods fill and stroke. Fill being I want to fill something solid, stroke being I want to like just draw something as outline. That's when it gets rendered to the actual canvas tag. So you could render things very quickly to the buffer, and then even change that. You could, if you really were like trying to do something super performant, you could write to the buffer a lot and then render to the canvas tag like every third time or something. If you're on like an old browser and you're really trying to like account for that. So begin path says start drawing to the buffer. Stroke and fill actually cause those to get rendered. You can use this context.isPointInPath before you call fill and stroke, and that'll tell you like if a particular point that you call out is actually inside of anything that you've drawn at that point. And then you call ctx.restore when you're done. So let's actually step through the JavaScript real fast. Same thing, reference, offset. Because you can see like this canvas tag is actually not at the hard edge of the page. And this isn't something specific to Canvas. This is specific to like any HTML element. Like if you wanted to get like, am I over this particular piece? Like, I don't know, there's a div containing this text. If I wanted to really figure out where this started, if it's nested in a bunch of stuff, I would have to like go to the parent and keep adding the left and the right of these. So I don't want to get too into the weeds here. Really, I'm saying get the start point, store it as the offset, and we're going to use everything from there, from the offset of the page. Like it's technically this is the top of the top left of the page. We're saying the offset is here. It's like a little bit over X and a lot down Y. We're also getting the mouse coordinates. As you can see, I'm moving around. Like this mouse would be like I don't know, like 500 right here and like 50.
Oh, so that's why, because it's pulling the mouse coordinates off the page.
Right. It's exactly. Thank you. It's pulling the mouse coordinates off the page. Like here is 0, 0 on the page, but here is 0, 0 on the canvas. Yeah, so you got to do a little bit of math in there to figure out where this mouse pointer is in relation to what the canvas thinks is 0, 0. So that's that offset and the mouse values here, minusing those offsets. So when I do this, the canvas thinks I'm at 0, 0, not here. So what we do is we call, we get the 2D context, we call save, we call begin path that says I'm going to start drawing to this buffer. We draw a rectangle out. At this point, we can say, is this mouse cursor within anything that I've drawn at this point? If so, set the current color to red. If it's not within anything that we've drawn, set the color to white. Then we call draw rectangles, draws those squares out. So as we move this around, it's constantly checking. Am I within anything we've drawn yet?
Does it keep drawing?
It does. Because it's a mouse move event, it runs anytime the mouse is moving. If I stop moving the mouse, it's not running anymore. So I can, as soon as I click inside of any, or not click, as soon as I move the mouse over anything in that path.
What if you have two squares? How do you determine,
You would do begin path, you would check, each square would have to do draw itself, right? It would have to be like two loops. You would say begin path, draw the square, am I in there? If so, turn white or red. And then you would have to do fill, and then you have to do begin path again. And basically each time you want to draw a square, it would be a begin path, check, and a fill.
So it only selects what's in the current buffer.
Correct. It checks everything that you've done since you called begin path.
Got it.
Right. Kind of complicated. We learned how to do event handlers on there. Does anybody any questions so far?
A lot of glaze.
I know, a lot of glaze. Yeah.
I think rect under the covers only really sets like the internal context to tell it where a rectangle would be drawn.
Right.
If you did stroke or if you did fill.
Right.
Like it doesn't actually
Just doesn't
draw.
matter.
Right. You could totally do begin path, create a ctx.rect, and never call fill, and it would never get drawn to the canvas.
Right. But then you could also just say rect and then a different rect, and it would just overwrite what the previous one was. And so you could just
It would have two. It would have two actually at that point.
Would it?
Yeah, it would have both.
It would have both.
You can do multiple drawing calls.
And stroke and then
And then stroke, and it'll stroke them all.
But then your is point in path would be checking both of those squares.
Right. That's what I was thinking.
So you have to do the begin path, draw the rect, check if you're in, fill it, and then begin path again, check if you're in.
A lot of glaze. That's okay. I love it.
So to continue that, if you did that, let's say, without separate begin paths, then your check would be true if you were over either
Anything, yeah. That's
rectangle in that case.
And that might be
But if you were somewhere in between them, no.
Right.
Right. Right, because it knows what it considers a rectangle. Right. So right now we've just done a bunch of like JavaScript. Like we were talking, like this could get super complicated if you had like multiple squares and you're like, am I over this one or am I over that one? I don't know, right? Right. So what you can do is you can start making life a little bit easier by using some structure. In this particular sample, we'll go a couple other levels, but this one, all I've done right now is kind of extrapolate these into some JSON objects. You think about properties, right? What does a rectangle have? It has a start point, start X and Y. It has a width and a height, and it has a color. Like in this case, one of those four colors. If we build out some simple JSON, you can see, we have four rectangles here with different start points. They all have the same width and height, and they're different colors. And because we can access this through JavaScript, it's the easier way than just writing everything out into like one long function. So let's look at the draw method on here. Kind of same stuff, clearing it all out. Right here, we're just looping through that array that we just created, rectangles, and we pull each one out. We set the current fill style to whatever that value was. In that particular array had like a rect color like orange or red. So we're setting the fill style to that. Then we're doing fill rect, and we're just pulling all the properties out of that array value, and we loop through all of them and draw them out.
So now you're implementing the JavaScript object instead of
Instead of like just hard coding everything in.
Canvas just draws no matter what. Like it says here, whatever my JSON is, just draw it.
Right. And we could go in if we wanted to. We could go in and change the JSON. We'd be like, oh, this one's going to be 200.
Yeah.
And, boom, it just goes to 200 at that point. So it's just, it's easier than like, we're trying to like extrapolate this out, make this reusable in some way, instead of just writing like these long drawing functions that nobody wants.
Yeah, so then you can do your own mouse event too on those and just
Yeah.
check the JSON at each time.
Exactly. We could change this a little bit, and
Way easier.
you'd still have one event handler on the canvas, and you could say check if it's over something, and change the color. And really, what you're doing is each one of these
Whatever is over property.
is over prop. Yeah, it would have its you would do begin path, check is over, set a color, and when you draw it out, it would be checking each one because it's in a loop.
Huh, that makes sense.
Yeah. So let's do this. It progresses as we go. Hope nobody's getting super lost. We can take that a little bit further. Last time we just had an array of properties. We can take it a little bit further and say also, instead of one big render loop that we were in, each object can have its own render. It can know how to render itself. And we do that by creating, if you guys are familiar with JavaScript, you just create a function. It mirrors like what you would do with the class. So let's do this. Let's create circle, circle, circle. Each time you do this, we're just creating a new circle. And we start out with an empty array. Instead of last time we had an array that we populated with like a bunch of properties. It starts out empty. We have a function circle, which allows you to declare a new circle instance. It would, if you guys are familiar with other languages like .NET or anything like that, we have a class, like a new class, essentially the same thing. This is class circle. Has some properties like its start points, X and Y, its radius, its color, and this base we just hard coded it to red. We could red it to be with something else. The angle is 360. This circle knows how to render itself now. It has a render function on it, which calls save context, set it to fill style, begin path, arc, fill, and restore. And so now we have another one, rectangle. So now we have a rectangle class. Kind of same basic properties. It knows how to render itself because it has a render method now. These buttons have event handlers on them. So I can create a circle, and really it creates a new instance of a circle with some random values on it and stores it in the shapes array, and then calls this draw method. Same thing, create rectangle. This button just calls this JavaScript function here, creates a new rectangle, stores it in the shapes array, and calls draw. So let's look at this draw method. Get a context, clear it all out. All it does is loop through that array, get the current shape, and call render on it. It says go render yourself. We pass in the context that we got from the canvas, that 2D context. We pass it in, and they know how to render themselves. They take that context. They do all of those methods. Set the current fill style, draw yourself, and then it returns, and it just loops through this, drawing each shape in that array.
Nice.
I'm gonna let it sink in for a minute. It's cool. It's a way to start adding organization and to your code. Any questions at all? People dropping off? No questions. All right.
No question.
No questions. Animate. How do you animate something with a canvas? If you guys are familiar with any sort of cartoons or anything like that, they're all done, especially the older style cartoons. They would just draw something like a clear overlay. They draw like a shape here, like Mickey or whatever. They take another clear plastic sheet, they draw Mickey slightly differently. They take another and they draw them slightly differently. It's like a flip book, right? And then they just play those over and over. And it's really a bunch of frames put together that look like it's moving. Essentially, any sort of animation is the same way. Like any computer animation, including Canvas. Really, what you do is you draw something, you update its properties, like its start and its X, start X and Y. You clear the canvas, you draw it, you update its properties, clear, draw. You just do this same loop. You do it fast enough, and it looks like everything's just running smooth at that point. So what I have is I have these same methods built out into an animate method, and then we could do them individually. So we could call move and then draw, move, draw, move, draw. We could call move a bunch of times. So we're updating the properties of this thing. Like we're moving the X value as we move along, move. It increases by like 20 pixels, and then we call draw, and it jumps way ahead. So if you don't call draw during that loop, I mean, you're just like updating properties at that point, and it just resets as it gets to the backside. We call animate. We're essentially doing that same thing repeatedly. Update properties, draw. Update properties, draw. I'm gonna reset this page because that gets super annoying. There you go. Let's look at the JavaScript for that. We're just building on what we did before. So we have this shapes array. We have this circle class, so it knows how to render itself. We have this rectangle class with properties that knows how to render itself. The create methods, create, circle, create. These are the two new things that we've done. We call move. So we loop through this array of objects that we created, and we set we get their current X position, horizontally in this canvas. We add 20 to it. And we're saying if you've reached the end of the canvas, just go back to the start point, and then we just store it back into the array. So really, we've just updated all the objects by moving 20 pixels to the right in that array. And that's all that move does. It doesn't cause it to draw or anything at that point. We broke out draw. It has its own function here. Get a reference to the canvas, the 2D context, clear it all out because we're going to redraw everything. So we loop through this shapes array, same as before. Yeah, pull out the current shape and say render. Because it had moved 20 pixels before, once we clear it and re-render it, it moves, on the dash. So that's how you do animations with Canvas. Is you just have these objects stored in, an array or something, and you update them before you draw them.
Maybe you said this, but how do you control the rate of that?
So no, this is good. This is one of my bullet points. Update the value of the object. So my bullet points on the animations. Update the values on the object. Once you're done updating, called render. And then use request animation frame if available for better performance or battery life. Animation frame, well, basically you're in a loop, right? And you would control the rate by saying when.
There's your time.
Right. You store when did I draw this last? And it gives you some like computer time. It's like, super long and very precise.
Milliseconds or something?
Yeah. What's it?
It'll be ticks, right?
Oh, ticks, exactly. Yeah. Which are like thousands of a
Number of
millisecond or
seconds.
something.
Oh, wow.
January 1st.
Yeah, exactly.
So those are big numbers.
Right.
Most JavaScript really goes back, is it milliseconds since?
It might be.
Yeah, I think.
Oh yeah, and JavaScript is
milliseconds.
milliseconds. Ticks are like computer system. Yeah. So thousands of a second, essentially. 1,000 milliseconds is a second.
Okay.
So it gives you this. You say, take the current time.
Right.
Draw this, and you're in a loop, and you just store that current time in a memory, and when the next
Wait
time
this
it
long,
moves through,
basically.
yeah, you're like, oh, if it wasn't, at least 10 milliseconds,
Yeah,
you can
don't
skip
do
it.
it yet. Okay.
Yeah, and go to the next one. Request animation frame is pretty popular now. I'd say, it was a new thing probably when IE9 came out, I believe. It wasn't supported before that. Request animation frame is like a drawing loop. Except that it's controlled not through JavaScript, it's controlled through the browser. It operates basically the same, but it always passes in a time method. So really what you do is you say, how do I describe that? Request animation frame is a timer controlled by the browser instead of through JavaScript. So it allows you to operate.
So the browser gives it to you. It says, here,
Right.
here's your next frame, here's
Right.
your next frame.
Right.
You can't control that.
Right.
You can just debounce it. Basically.
Right, exactly. Because it passes in a time value, what you can do is check it. I'm not doing the check here. What you would do is you would say, if it hasn't been a certain number of milliseconds,
Right.
don't draw.
So outside of that request, you have a variable that says last time or something.
Yeah.
And then inside, you're like, okay, if time is last time plus 10, then go ahead and do this.
Right.
Otherwise, get out of here.
Actually, the
That's
other way
how you-
I've seen this done is that you take the move method out of the animate and just run that on just a set interval.
Right.
And because it's not doing any drawing, you don't need a request animation.
Right.
You're just updating
And
internal state.
request like a set interval in JavaScript would definitely be a good fallback method. And I will, depending on what browser support you need, I probably wouldn't keep doing that in the future, only because it's a JavaScript-based timer and it tends to eat up more memory and time, battery life, etc. If you're especially on a mobile device, and that's why they created request animation frame.
Yeah, because it's based off the render engine. Render engine knows
Right.
like, okay, I'm ready to render something else.
Right. it's controlled outside of JavaScript. So yeah, you could be in a JavaScript set interval, and you could start collapsing. Like if you have a set interval that runs every 500 milliseconds, but it takes 600 milliseconds to draw your frame, you start like overlapping, and it builds up. You'd be like stop, and it'll keep playing for until it's done with its stuff. Versus request animation frame, because you can kind of control that a little more and say, oh, if I'm you can control. I'll just leave it at that. But yeah, set intervals definitely was a good fallback for this.
Well, right, I wouldn't recommend using set interval for the whole thing, because a request animation frame is, I believe the browser kind of determines, hey, here's the appropriate number of times that I can call you, and it sets itself up to be called for doing animation.
Exactly, yeah.
But whereas the set interval thing, I was just saying, just use it for just updating the internal game state, just the internal values that have nothing to do with Canvas at all.
Yeah, that's true. Yeah. So we learn how to animate. Really, it's move, draw, move, draw, move, draw. Kind of like you would animate anything at that point. Transform. Okay, so we're getting close to the end here. This is like the last actual walkthrough piece that we do. Let me close this really fast, because I have a bunch of sliders down here. We can control the height, the width. We can skew. These are methods that the Canvas gives us right away. We can skew something. We'll skew Y values as well. Translate we saw before, where we could just like move something left and right, and then rotate is roughly the same thing. And as I move these sliders, it's doing the same thing before. It's updating a value, clearing and drawing, updating a value, clearing and drawing. So let's look at what's happening though. I didn't skip one, did I? Let me just make sure. No, we did animation, which is fine. And that was like move and update, perfect. Bullet points here, the takeaway. You can combine several of these manipulations into once and call context.transform instead. So like we did translate before, like translate in 0.5, and then do some drawing. We also had to rotate, like ctx.rotate, and it rotated our start point, and then we could draw something. You can actually combine several of those at once. And there's one method, transform, that takes in like the current translation point X and Y, the current width X and Y, the current skew X and Y, and it allows, like if you're going to do something like a bunch of those at once, it's easier/better to do them all at one time instead of calling multiple updates. Except for rotation. You could do rotation along there as well. It just takes some math. So I tend to break those two calls out. I'll do two calls if I need to also do a rotation transformation. Let's look at the code a little bit. Same kind of, we have our shapes buffer. This is new for us. It's a new transformation. So you can see it's like a new instance. It's because I created a class down here. Transformation. It just has a bunch of properties, right? It has insertion point X and Y, width X and Y, rotation, and skews. So I could take this transformation, I could apply it to any of those shapes that I've done. I could be like, this one particular square gets these transformations, this one particular circle gets these transformations, and then you can do that all through JavaScript in the back end before you render it. So, and we have this apply method. It really just updates a bunch of stuff on the context before we draw. This is why I broke out, technically you could do set transform and include rotations in there, but you have to do all of this math inside and multiply it by like these widths and skews, and it gets kind of ugly. It was just easier to break it out into two calls here for me. So set transform, and then I also do a transform, which is sine and cosines. It's really a way of kind of grouping stuff together and making it a little more structured. So look at the draw method. Same stuff before, we're clearing it out. We're saving our current settings. We're pulling all of this insertion points, rotations, etc., all from those sliders that we had down there. So we're getting those values, width and height, and then we're calling apply, and we're passing in the context. And let's just go back up and walk through that. Apply, we pass in the context. So we call set transform, which is the method Canvas gives us to update all of these at once. Then we figure out our sine and cosine based on the rotation that was passed in. We also call transform on that. And let's just pick up again.
Go back up real quick.
You want the apply
No,
method?
no. A little bit more. Okay. So no, go ahead. I'm sure you're gonna cover it.
So let's just recap. So we created a transform object. We pulled all the values from there. We applied it. So we basically updated the canvas, like drawing points and stuff, and said where where are we going to draw, and then we draw these two shapes that we created. We just looped through a buffer. I think I created these on the window.unload. I just created two shapes right away and stored them in this shapes buffer. So because I knew we were working with them, right? It's not something I need to keep creating. So in my draw method, we just loop through, there's each of those two shapes, and we just call render, essentially. And the shapes themselves don't know how to skew or change their width. We had done it all on the canvas prior to drawing, right here. So if you wanted each shape to transform differently, what you would do is you would create a...
You're like manipulating the context itself first, and then drawing, like normal.
Yeah, if you wanted each shape to be able to have its own width and height and skew, you just come in here and add a new property transformation, and it would be one of those transformation objects, and you could keep setting you could be like, okay, this red circle has a skew of 2 in the X position and a skew of 1 in the Y position, etc. So all those properties would then get stored per shape, and then when you rendered it, you could apply that before you rendered it. A little vague there, but
Do that begin past that thing, right?
yeah.
Begin whatever it is.
In this case, we just did it for the whole canvas, so you can see it applied to both. I think I scared everybody away from canvas. Now they're like, nope, that's
not touching that.
No, go ahead. I'm sorry. Yeah, I can go back if you need me to.
So I might be actually way off topic, but I'm wondering right now is if I'm rendering something, is there a way to make sure that my updates finish before the next browser render tries to render it? So I'm not changing it and rendering it multiple times. I'm only rendering.
Yeah, you would do that with the request animation frame. And
to me, it seemed to be like a timeout type function where you say render, because you can say you must execute this code.
Yeah.
But you don't know that it's going to do one render. It may do multiple.
Yeah, I kind of see what you're saying. You would almost have to track, like, how do you know that the canvas is done rendering? Really, right?
Well, it's
Yeah,
not gonna,
the problem is if
interrupt
you call that function before a render, it may actually be doing its work over the series of multiple renders. So I'm saying it may be actually more performant to finish all that work than render.
Right.
It's
I
all
think that's what it does, though. Right?
No, it's all single threaded. There's nothing that's going to start another render while the first one's running.
Right, that's why when
Perfect.
you request. So
Perfect.
that's the
Yeah.
difference between timeout, because timeout you set it, you say,
Okay.
I want it 300 milliseconds, and you're not sure if that render's going to take a second.
So it will complete
The
the
request-
code before.
Before it
renders.
comes back to you, because that request
Okay.
animation frame works on a callback, so it's
Because, yeah, the
request it,
documentation wasn't clear on that, so I wasn't sure, at least what I read through. Thanks.
I think they did a better job at answering it. This is great for me. I love it. Last one. Compare SVG to Canvas. I knew you asked this earlier, like, why do you use Canvas and not SVG? You use Canvas when you're awesome and SVG when you're not. No, I don't hate SVG. I don't. It has its purposes. No, so this. Let me lose this because we don't need this anymore. I say you hate XML. I just don't like it's not XML per se. It's the structure, the
hugeness of it.
the hugeness of SVG. Yeah, like, oh, I want a circle, and you're like, okay, new circle, and the attributes and all the stuff, like XML syntax of that. I hate of SVG per se, but so you're awesome. Your drawing area is under 1,000 by 1,000. Unless you have like a smoking computer, when you do get a canvas that's pretty large, you do notice some rendering timeouts and stuff in there. You're like, wow, this is killing me here to render. And you start getting like weird skip frames and stuff happening. So I've found, even with hardware accelerated canvas in the browser, that under 1,000 by 1,000 is optimal at least. You can definitely go over it. Depends on how performant your computer is at that
And you
point.
can overscale your canvas so that it's like rendering, like it believes that it's 1,000 by 1,000, but it's actually rendering out 2,000 by 2,000.
Right, and I think you might run into some granularity problems there, like clarity
Yeah.
problems. But yeah, depending on what you're doing, that might be okay.
Right. But if you only got like a few animations, you're probably okay, right?
Yeah.
If you got like a ton of stuff going on.
Yeah, exactly. Yeah, a ton of stuff. Like if you're drawing, you're like And even then, like honestly, you could probably go more than 1,000 by 1,000 if you start optimizing your code on the back end. You're not doing a bunch of draws and calls, right? You're not doing a bunch of fills and a bunch of strokes when you don't need to. If you can draw to that buffer first and then like kind of fill and stroke everything at the end, that actually gives you better performance. And so you could probably go more than 1,000 by 1,000. So it's you got to feel it out a little bit, but a general rule, that's what I found. You need pixel level access. That's definitely one thing SVG doesn't give you. If you wanted to build your own drawing app where you have a brush that creates random leaves as you drag it along, you're not going to get that with SVG. You could totally do that with Canvas. Using patterns and images and stuff like that. And you literally have pixel level access. You can say this pixel, and make it orange.
Yeah, Canvas would be like Photoshop, and SVG would like be like Illustrator. Right?
Perfect example. Yeah, perfect examples. You need special blending on your objects. We looked at that cheat sheet earlier that showed like overlay methods, boring, etc. They blend together, they boolean themselves out. That I don't believe is available in Canvas. I'm almost positive it's not. It's definitely available in SVG. Yeah, it's definitely available in Canvas. The caveat being that they're not like, I know Firefox handles those a little bit differently. So those aren't 100% the same across all browsers, those blending modes. So just be aware of that. Some of them are, some of them aren't. There's like 20 to choose from, and some of them are the same across all browsers, some of them are not. When you think about what SVG is, right, it's roughly the same as the stuff we've done on Canvas. SVG is describing how to draw something through vectors, through points and arcs, etc. And that's why it can scale and not get blurry, because it just scales the values up. Like an arc here, or an arc this big, it doesn't render out the pixels first, it re-renders them. So in a sense, you really can create SVG in Canvas, because SVG needs some sort of container to present itself in that knows how to scale and render its contents. Roughly, we've created the same thing with Canvas. You don't get the syntax of SVG and the ease of use of SVG. So another reason to use Canvas, you want to export your creation as image. You can right-click on the Canvas tag, save as image, and that's actually super useful. You can take that image and then re-import it into Canvas. So you could have this draw cycle where you're mirroring your own canvas. Exactly. It's like you could draw a square on this side of the canvas, post that out to an image in memory, and then apply that image, or you can redraw that image right back onto canvas. And it happens super fast. So you can literally mirror your own canvas in one draw call. And so you can do some crazy stuff with that. Even down to the point that you wanted to like do a graph for somebody, like you have a web page and it builds out this graph, you could right click and save this image. Use Canvas if you can cut off your browser support at IE9.
Which we all do nowadays, right?
Yeah, exactly. Yeah, it's not a big deal anymore. I don't like the syntax that it's not even the markup language technically of SVG. It gets pretty hairy if you're in the thick of it. And then don't forget about the cheat sheet. Really, there are not a lot of methods to the Canvas tag. It's a matter of like knowing what they do and building up on them. Like, draw art, draw image, create a pattern, so like that. So that cheat sheet, 2 pages, and you've done everything with Canvas at that point. SVG, well, you need to draw over a large area. Yeah, SVG is great for that. You want to take advantage of the scalable nature. It's just a lot easier in SVG. You don't have to do all of that math and stuff yourself. You're like, hey, it's bigger now, draw yourself. You don't need pixel level access, like you're dealing more with shapes, etc. You don't need to draw a brush, re-render Photoshop brushes. You want to easily bind to objects. SVG, like you can have an SVG container with like 4 circles on there. This circle, you could just write literally on mouse move equals this tag directly.
So it's actually a DOM object.
Yeah, it's a DOM object. Yeah. So it's much easier to deal with interacting with those particular objects. Dealing with a lot of text. Canvas is strong point, definitely not text. It does have a lot of text methods. You can do shadows, etc. They start to get a little wonky across different browsers, especially text shadows. I found it's not the strong point of Canvas, but it definitely it's capable. So it depends on your needs. SVG has
on top. Anyway.
Exactly. Yeah, and that's another method is because the Canvas tag is an HTML element, you could layer text right on top if you needed to. something to consider. But SVG, I mean, the text on SVG is like just miles ahead.
Well, SVG is a tag too, so you could do the same overlay.
Yeah, that's true. Yeah.
You're in the same code.
I would say SVG. I say performance isn't necessarily a factor, like video games, and I think that I would say that because it's rendering out the I don't think SVG, it is a DOM element. It's getting
It renders with
it's,
DOM, right?
right. It's not getting rendered with the. I don't know that SVG is hardware accelerator. I don't think so, but yeah, definitely you're not going to be building high-end games anyway with SVG. You want support for older browsers. I think SVG like it goes back to IE6, I believe, even support. So depending on what you need and cutoffs. Something I found with a lot of SVG stuff is like you can do so much with CSS transitions. You might not even need SVG at that point, but it maybe not. I'm not an SVG guru for sure. Third-party libraries like Kinetic.js is a big one for Canvas. There's a 3JS if you want Canvas 3D stuff like WebGL. Kinetic.js is I don't know that it's only 2D, but it definitely offers 2D stuff. SVG Raphael.js is a popular library. So wrap up. What do we talk about when we're working with a Canvas tag? You want to get a reference to the Canvas element, right? You have a Canvas tag on the page. You want to just get a reference to it. You want to get the context. You want to call it context saved to save any of the current settings before you start drawing stuff. And you want to do begin path to start rendering to a buffer. You want to use the draw methods like rect, arc, and line to draw to that buffer. And there's a couple more that we didn't touch on per se. Use the render methods fill and stroke to actually write the buffer to the canvas only when needed. So kind of keep your performance up. And then you can modify the entire canvas context with those transforms like translate, rotate, etc. And so if you want to rotate this before you draw it.
Nice.
I didn't realize that I don't know. I feel like it's a little complicated now, more so than I felt it was. So hopefully I did a decent job of bringing it, making it, you're familiar with how to work with Canvas now, hopefully. You have some exposure to it, if nothing else.
No, very good.
Oh, well, thank you. Thank you. I apologize for the second slide where I was like trying to explain begin path. I feel like we got past it. Just to wrap up, begin path allows you to start drawing to a buffer. And that's the reason you would call it first. So.
We got time for more questions? Or
I'm
we
down with questions. I have time for questions. So.
8.
Or do we have somebody? Okay, so nobody else is going up. So yeah, I'm coming from trying to create a drawing program.
Okay.
Kind of
Like
context
Photoshop
here.
or something?
Yeah, or more like more or less exactly what Google Drawings lets you do. It lets you do all this kind of stuff, shapes, relatively simple things, but you can do things with shapes and text and stuff. But it also lets you put hyperlinks in there.
Yep.
And images and stuff like that. But actually, so I want to ask you about some of that stuff. But also, so if you're creating an app like that, and you want to create these things, and you want to save them, and we'll open them up later.
Yep.
What's involved in that? What is it you're saving?
You saw earlier when like we created like this buffer of
Right.
shapes. It's an array of shapes, and it basically was like a bunch of properties.
Right.
Through code, you can write that back out. You could submit those values. If you were going to save those, you'd probably save them to a server somewhere.
Right.
And so really, you have all of these shapes that you've created in memory at that point.
Right.
Because you drag a new square on there,
Right.
and it says, oh, as soon as the mouse comes up, he created a square. I know the start position, the width and the height, and maybe some other properties, and you have that stored in this buffer in memory. So you do that with a bunch of shapes. And if you want to save that, because those are all in memory, you would just do like an AJAX call to a server and say, hey, here's all my JSON objects. I store it. Well, it would render out to JSON quickly, actually. So you just push all this JSON up to the server with some other properties like drawing name, etc. And you just build a method on the back end to take those properties, dump them straight into a database. I mean, you can do some validation if you want, but essentially you're taking all that JSON, storing it into one column in a database table. And when you want to open that up, all you do is read that back in, fill that shapes buffer, and you can just redraw everything right back out again.
Cool.
Yeah.
So next question, what about those other things? So you want, just as an example, you want to insert an image.
Okay. Yeah.
I mean, what's
involved with inserting an image into
Yeah.
Canvas? Let's
kind of have a guess after
look at that cheat sheet again.
what you showed, but
that's on the internet, I don't know if you have a link. The cheat sheet.
It is on the internet, yeah. You know what, there's a link right on the top of
It's
it.
blog.nini,
Yeah, if you-
NIHI log.
Literally, if you Google HTML5 Canvas cheat sheet,
This is the way
it
you
shows up.
Okay, it's kind of the one.
Image. So in order to draw an image, if you can have an image stored in, what was that, base 64?
And I'm talking like a photo, like a JPEG, like a
Okay,
A
so
photograph
yeah,
or
let's,
something, okay.
let's keep it simple for now.
okay.
So you have a photo that you want to like drag onto the canvas and draw it. The way Canvas works is with an image in that scenario, it would have to be an image that's already been like, you'd have to have an image tag on image tag on the browser, or like within the DOM rather. And you would reference it. You'd say, hey, go get that image. And then there's a drawing method like write image, I believe. Let's draw image. It's here. And you take something in. It says object image. It's because it allows a lot of different things to come in as an image. It can be a clip that you've done from another part of your canvas. You could be like, hey, go kind of snapshot this piece of the canvas. And you can store that in memory, and that could become your object that you pass into this draw image, which is how you do that, like mirroring that we talked about. So essentially, it says draw ctx.draw image, and it passes something in. In this particular case, it would be like if you have an image tag, you would say var I equals, get document by element, or get element by ID, your image, something like that. And so now you have a reference to that image stored. You would literally pass that right in here. So you ctx draw image, you pass that variable right there. Where do you want it to start and end, or excuse me, where do you want to start an XY on the canvas?
Okay.
And then you can also set a height and width on there if you wanted to.
So to clarify, if you want to put a video in there, do you have to call this multiple times with a different
Yes.
image each time?
Yep.
Okay.
Exactly, and you can totally do that. You can have an HTML5 video element on the page, and when you do that, you can have you can say next on that element. You have frame level control on an HTML5 video element. You can say next. You get a reference to that particular image, and you draw it. You like next, get a particular image, or get that image and draw it. That's how you put video onto a canvas tag.
So if you want to spiral a video, then you do that.
Oh yeah, you totally do exactly. Yeah, exactly. And you would do like a transformation before you call actually draw an image.
Still playing in Windows. And stuff.
Yeah, exactly.
Yeah.
Now all
Yep.
the videos are going to be moving. Technically, you could do that with HTML5. Oh, you could rotate it.
Yeah, you could. Yeah, you could with CSS transformations and stuff. Yeah.
Be slower.
So to create something like that, I mean, how much of it's JavaScript? How much of it is this? It's like most of it's JavaScript, and
Yeah, like aside from like the canvas tag itself as a DOM element, when you're working with Canvas, 99.9%
right,
is JavaScript.
right.
Okay,
Okay,
but you know, you
even
can
more
start
than I
small.
thought.
But you can start small. Like, can I draw a square? Can I? Then can I export that out and make it like it's not just like one big drawing with everything in there? What can I pull out into other
Right.
functions and start breaking it out and building yourself up a nice little library essentially.
Right.
Or there, depending on what your needs are, I mean, you can reference one of those commercial libraries. And
Yeah.
I said commercial,
Yeah, one.
other third party.
Yeah.
Definitely.
Are there other ones besides Kinetic that you recommend? Or?
Easel.js.
Oh yeah. One of them, I don't remember the name of it now. One of them I really didn't like. It seemed really slow. Like it was built for convenience, not for performance. So, and then when I was doing my stuff, I really didn't use a third party library because I didn't necessarily want to deal with like licenses and things like that. So.
What do you remember what it was? Or?
No, I would just Google third-party library.
Yeah,
Like,
okay.
I think they've changed. Other than Kinetic, you said Easel. 3JS, I may have some 2D methods on there, calling methods. I would just Google it and kind
Right.
of
Okay.
review off of that because they developed over time.
There are a lot.
Yeah, well, that's the problem. That's why I asked though, because that's the problem is there's a lot, and
Where
then you
do
go,
you-
which
where do you
ones
dive
suck
in?
and which ones
Yeah.
don't,
So
so
the thing about
it's hard to know sometimes.
Kinetic and Easel are actually kind of the same makers. So Easel is like for actual drawing piece of it, and then Kinetic is like to move stuff around. That's from what I understand. I don't know if maybe you have a different experience, but
So maybe you use them
no,
both.
like it's been a while since I worked with the
Yeah.
third-party libraries actually, just because they weren't fitting my mold.
But the performance thing's not really a big deal unless you're doing animation stuff like that, right? If you were doing something like I described, I mean, do you really care that much, or
I don't think so.
You still do.
I always care about performance.
Yeah,
for
because
Rails.
like, if you don't, and then like later on.
Yeah, later on, you're like, oh,
I
I
mean,
mean, the animations, my
yeah.
entire
But
thing
it's
is built on this, yeah. Yeah.
Oops.
Well, I definitely get it for battery for sure. If that's part of what we're talking about,
Yeah.
then that always matters for sure. Yeah.
You would care about it on your initial render probably a lot more. Oh, but then you wouldn't because it's always a full render.
Well, and it renders where you're as you go, right? When you're just
So I
drawing.
really don't think it'd be a big deal for a drawing. It's just drawing a picture,
You
a little bit.
what was Disha saying? You had some input on something having to do with this. I forgot.
Well,
SVG.
next time, I'm
It's just
gonna show,
SVG.
I was playing with an SVG-based library,
Right.
right? But I'm just doing charting, so there's no,
Right.
I'm not messing around with any kind of animations or
Right.
or so forth. And frankly, like I said, we were saying, you could use any of them because the libraries are all fairly similar in terms of their methods, right? And it's just trying to find one that, kind of does what you want in a way that you're comfortable playing with. But I can't say that they make a lot of difference in what you're playing with. And I may not even end up sticking with the SVG. I may even, try doing some Canvas stuff and put them side by side and see what I like better in the long run.
Right.
But for that kind of thing, it was about the same, and I didn't have to deal with, let's say, most of the major, let's say, shortcomings of SVG. Chris pointed out. I am lame, so I'll.
No, I did that for
The rest-
comedic relief
that's
as well.
SVG is an exciting way to do your icons, I think.
Right, but I didn't have to.
Oh, yeah, yeah.
I didn't
But
have
for
to
this
do
stuff-
any XML. It was also, it's all JavaScript.
Sorry about that. Can you?
In that case.
And there's no request either with SVG icons. Like you don't have to request an image. It's all in the browser already. Right now.
Yeah.
So rendering.
Thank you.
The files for that are all on your desktop.
Okay.